Hello everyone, welcome to the Modern Networking lecture series. This is lecture number 4. In the previous lecture, we discussed about the cellular networks as well as cloud computing. Now today we'll start with the topic Internet of Things and one more topic, that is the network convergence. So why are we studying this Internet of Things? Because this topic, Internet of Things is also one of the primary contributors to the modern networking. Okay, more and more devices are being added every day. Okay, and we have large amount of devices which are contributing data, and they are actually adding more and more data, and more devices are being added. So the whatever networking structure we had, okay, traditional networking structure, so it is unable to cope up with these things. So we will see this. So this IoT, the Internet of Things, is a term which refers to the expanding interconnections of smart devices ranging from appliances to tiny sensors. So this IoT is it consists of large number of devices, okay, and they may range from very tiny sensors to big appliances. So a dominant theme is the embedding of short-range mobile transceivers into a wide array of gadgets and everyday items, enabling new forms of communication between people and things, and between things and themselves, between things and things. So here in this case we have a short-range mobile transceivers, transmitters and receivers, okay, which consists of varieties of gadgets, okay, which we use in everyday life. So we are connecting the devices, the sensors, to internet and control their behavior through internet. So IoT is primarily driven by deeply embedded devices. Now whatever devices we are using in IoT, they have low bandwidth, okay, and they have low repetition data capture and low bandwidth data usage appliances. So this consists of this one, but they can communicate with each other and they can provide data through various user interfaces. Okay, so this IoT is communication between people and things, and between things and things. Okay, and these devices, they are low bandwidth, okay, and they don't have any repetition data capture, and they also have low bandwidth data usage. Okay, now the evolution of these systems. So with reference to end system supported IoT, the internet has gone through 4 generations of deployment, culminating into the IoT. So the very first is information technology. Okay, this will see the 4 generations. So this IT, it consists of PCs, servers, routers, firewalls. Okay, so this, they are brought as IT devices by enterprise IT people, and they are primarily use wired tech connectivity. So this whatever devices, they are primarily using the wired tech connectivity, and they are brought by the IT people. Then we have operational technology, OT. So in this case we have machines and appliances with embedded IT built by non-IT companies, okay, such as we have this medical machineries, and we have SCADAs. SCADAs means those devices which can supervise, they have supervisory control, and they can also acquire data. Then we have process controls, kiosks, etc. So these are also devices which are using the wired connectivity. Then the third one is the personal technology. Now this comes these devices such as smartphones, tablets, e-book readers, etc., which are brought by IT, which are brought as IT devices. Okay, and they generally have wireless connectivity. Okay, then the last one is sensor or actuator technology. Now these are generally they are single purpose devices, which we call as embedded devices. We can say they are made for particular application. Okay, so these are single purpose devices which are brought by consumers, IT and OT people. Okay, generally they have wireless connectivity. Okay, so they are generally of a single form, and they are part of a larger systems. Now this particular generation is usually thought of as the IoT, okay, and which is marked by use of billions. Now the layers of IoT. Okay, So IoT, it consists of 5 layers. The first is the sensors and actuators, which we called as the things. So sensors, they observe the environment, okay, and they measure some physical quantities such as temperature, humidity, okay, presence or absence of some observable. Then we have actuators. So actuators, they operate on the environment, such as changing a thermostat, sensing or operating a valve, okay. So they do some actions. Then we have connectivity. Now a device may connect either through a wireless or a wired link to the network, because it has to send, if we have sensors and actuators, so they need to send and collect the data, okay, and maybe they need to send the data. So we need some type of connectivity, okay. It can be either a wireless or a wired connectivity. Then we have the capacity, the third layer, the networking support. So capacity, we can see, is the network supporting the devices, okay. So this must be able to handle a potentially huge flow of data, okay. It may happen that a single device may be sending less amount of data, not that much large, but because the number of devices is very large, so the data may be very large. Then we have storage. So there is a need to be that to store large data. So we must have a large data facility to store and also maintain backup of the collected data. And finally, data analytics. So for large collection of devices, so if we have a large number of devices, sensors, okay, so large amount of data will be generated, and to get the actual data, we need to do some data analytics, which is coming from various sensors or various devices. So the data may not be useful only from a single device, but the actual useful data may be from the number of devices. So you must have something called as data analytics, so that the actual data could be understood. Okay, now next topic is network convergence. Okay, so network convergence, it refers to the merger of previously distinct telephony and information technologies and markets. So in this case, we are just converging the previous technology of this telephony, okay, with the current one. Now convergence, it can be thought of a 3-layer model, okay, with respect to the enterprise communication. The first is the application convergence, second is the enterprise service, and third is the infrastructure. So the application convergence. Now what is application convergence? So application convergence integrates, actually combines the communication application such as voice calling, which is telephony, voicemail, email, instant messaging, and all this particular we are just we are making convergence, or just integrating all this type of communication, voice, data, etc. Now with convergence, applications provide rich features that incorporate voice, data, video in a seamless, organized and value added manner. Okay, so we are just combining all the communication, just we have data, maybe we have voice, so they are combined together. So just an example, we have multimedia messaging. Now this multimedia messaging platform, it enables a user to use a single interface, okay. So the user can use a single interface to access varieties of messages from various sources. Now the message can be in a form of office voicemail, it can be an email, it can be a SMS text message, or a mobile voicemail. So whatever messages which are coming from various sources, it can be accessed through a single user interface. Now next is the enterprise services. Now this is concerned with the network manager. Okay, this is concerned with the network manager. Now in this case, the network manager ensures that the users, they take the full advantage of the applications they are using. Okay, so network managers, they need to make sure that appropriate privacy mechanisms and authentication services are in place to support convergence based applications. So whatever applications we are using, so some mechanisms, they must be in place. So this enterprise services is concerned with that particular case. Okay, and they may also be able to track users location to support remote print services and network storage facilities for mobile workers. Okay, so it may also have services including setting up of collaborative environments for various users, groups, applications, and quality of service provision. Then we have the infrastructure. Now the network and communication infrastructure is, of course, we require this, and it consists of LANs, WANs and internet connections. So enterprise network infrastructure also includes we have private or public cloud connections to the data centers, and it also has to host large volume of data. So we need data storage and web services. Now the key aspect of convergence at this level is to ability to carry voice, image, video over networks that were originally designed to carry data traffic. So the networks which were designed to carry only data traffic, with this convergence technique we can they are able to carry other type that data like voice, image and video, etc. So infrastructure convergence can also occur for networks that were designed for voice traffic. For example, we have this video, image, text, data, they are sent through the voice traffic, okay, over the cell phone networks. Now next we have the topic that is IP network convergence, which is related to that convergence topic. Now convergence, it brings many benefits, which includes simple network management, increase efficiency and greater flexibility at the application level. Okay, it becomes easier. So there are three key benefits of IP network convergence. The first is the cost saving. Okay, so a converged network can provide significant double-digit percentage reductions in network administration, maintenance and operation costs. The very first benefit of IP network convergence is that the cost, there can be a significant cost reduction, operation, okay, costs in terms of operation cost, and network administration maintenance is also reduced. Okay, so in this case, converging legacy networks onto a single IP network enables better use of existing resources and implementation of centralized capacity planning, asset management and policy management. It becomes easier. Then effectiveness. So the converged environment has the potential to provide users with great flexibility irrespective of where they are. Okay, so the user, it can get great flexibility with whether the user is in any location. Okay, so IP convergence allows companies to create a more mobile workforce. So mobile workers, they can use a private virtual network to connect to remotely access business applications. Okay, they can be anywhere and they can connect to the business applications using this virtual private network. Okay, so a VPN helps maintain enterprise networks securely by separating business traffic from the other internet traffic. So if we create a VPN, it of course it will use the internet, but it will create a secure channel so that it can be separated from the other internet traffic. The third one is the transformation. So because they are modifiable, and they are interoperable. So converged IP networks, they are modifiable and they are interoperable. So they easily adapt to new functions and features as they become available throughout technological advancement without having to install new infrastructure. This is one of the great advantage. So suppose in future if you want to make some changes, some technological advancement, so it becomes very much easier with this converged IP networks. So this is one of the advantage. Okay. Now the next topic is unified communication. Okay, which is of course related to the network convergence. So this topic comes under this. So this is not a new topic, but it is related to the network convergence which we are studying now. So this unified communication, it focuses on integration of real-time communication services to optimize business processes. Okay, so IP is the cornerstone of which UC systems are built. Okay, so it is based on this IP convergence. Now some of the key elements of UC include UC systems. They typically provide a unified user interface and consistent user experience across multiple devices and media. Okay, we just require a single user interface. So using this single user interface, multiple devices can access various medias, just like text and other like videos, etc. Now UC merges real-time communication services with non-real-time services and business process applications. So there are applications, there are communications which are real-time communication, and we have non-real-time communications. So this unified communication, it merges all these services into one. Now this is the, you can say, these are the elements of unified communication architecture. Okay, so we have various applications, like we have web conferencing, video conferencing, then audio conferencing, and see all these are the real-time application. This is the real-time application dashboard. Okay, and then we have some more layers are there: IP enabling content centers, then IP mobility, converged IP wireless infrastructure. Okay, and then we have the service called as network optimization, management and security. So the key elements of this particular architecture, okay, of the real-time communication, as we can see, the first one is the real-time communication dashboard. Okay, now this is one of the primary component of the unified communication architecture. So this particular element, it provides UC users with unified user interface across communication devices. Okay, so this RTC, that is real-time communication dashboard, it provides access to real-time communications, such as you can see this instant messaging, audio, video conferencing, etc. And then apart from this, you can see this web conferencing is available. Okay, so users can in this particular web, through the web conferencing, many users, they can share their contents, okay, through web conferencing. Then we can have audio conferencing. With audio conferencing, various users, they can connect with each other with voice, transmitting voice, communicating only through voice. Then we have unified messaging. Okay, now in this particular unified messaging, we have a common platform for message from multiple sources. So it allows users to retrieve email, voicemail, fax mail, etc. from the computer or the mobile devices. Then we have instant messaging. Okay, so in case of instant messaging, we have this is the real-time text-based messaging between two or more participants. Okay, so this IM or instant messaging, it is similar to the online chat. Okay, and then we have video teleconferencing. Now with video teleconferencing, various participants, okay, in this case number of participants are less, they can share their videos, okay, and they can communicate using this particular video conferencing. Then we have the presence service. Now the capability to determine in real time where someone is, okay, how that person prefers to be reached. So this is the, we can find the presence of any maybe any of the employee, etc. Then apart from this, we have this IP enabling contact centers, and we have IP mobility and the converged IP wireless infra. These are the various key elements of unified communication. So that's all for this particular session. Okay, thanks for watching.